Okay, so I've drawn a little line here. There's a couple other questions that are kind of interesting. So if you kind of enjoy geeking out over some of the details, then by all means follow along. I'm happy to go through this with you. I enjoy that to a certain extent too, and I hope that this is illuminating in some sense for you. So chance of producing, what is the chance? So what if you asked, what is the chance of producing exactly one block if the pool's active stake is 10 million? Of course, this is for Epic 212 only, because the total active stake on the network is going to change from Epic to Epic. And again, I will update that in the web page tool, so it will work for whatever Epic we're in. So remember, what we just got done calculating was the probability of at least one. So, if it produces 2 or 3 or 4 or whatever, all of that is rolled in to that other probability. So the probability will produce at least one. Now what we're asking, what is the chance of it producing exactly one block? One block but not 2 blocks. One block but not 3 blocks. One block, not 0 blocks. Okay, so what is the probability of exactly one block? And so the probability of success, again, is exactly the same number, and the probability of failure, they're both exactly the same as before. We're assuming 10 million stake, a total active stake of 12.10 billion. So how are we going to do this? Well, I think probably the simplest way to reason this out is like we did before. Would have to enumerate or count out the different ways that a stake pool could make exactly one block. All right, and so just follow along here and see if I've developed a way here to actually list out or count the number of ways that a stake pool could make exactly one block. So let's imagine case 1. So case 1, we're going to imagine we have the slot where block 1 is produced, the slot where block 2 is produced, and so on and so on for block 3, block 4, and all the way out to block 4,320. So these are not fractions here. I'm just sort of drawing a line, and then we fill in on top of this where where we're at the slot where block 1 will be produced, and then we have the opportunity to fill in here whether the stake pool will be successful or fail. So one way that the pool could make exactly one block is for the very first block that's produced in the Epic, it's successful. And then it must fail at every one of the other opportunities all the way out to 4,320. And that's case 1. So the probability here would be the probability of success times the probability of failure 4,319 times. Okay? So, but there's another way. This is not the only way that the pool could make exactly one block. So what's case 2? Case 2 is, let's imagine that it's successful in the slot where the second block is produced. So it fails to produce in the first block, or the slot where the first block is made. It fails. It succeeds here, and then because now it's had one success, it must fail in all the rest of them out to there. So I think you can kind of see the pattern here. The way to list it out is, we could say, well, maybe it'll succeed here for block 1, maybe it'll succeed here for block 2, and then case 3 is, let's imagine it succeeds in block 3, and so on and so forth till you move S all the way out to the last slot, block number 4,320, and case 4,320 is the case where it fails in the slots where all of the blocks are produced except for the last one. So it gets that last block, right? So what this means is now we've made a list of all the possible ways a pool can make exactly one block. And how many different ways are there? Well, there's 4,320 different ways, distinct ways, that the pool could produce a block. And so that's going to be important information for us. So now we can ask ourselves, well, what is the probability of it doing it? Well, you have case 1, so we need to know what's the probability that case 1 could happen, what's the probability that case 2 could happen, and then all the way down to case 4,320. What is the probability that that happens? Now, we know that one of these will happen. We don't have to have that case 1 and case 2 can happen. Why? Because they're mutually exclusive. If you have success in one, you can't have the success here. But this is a possibility. So what we would do in this case is once we have the probability for case 1, we'll sum it with the probability for case 2, because this is the, a second way that this could happen. And so we'll end up summing all the probabilities of each one of these individual cases up 4,320 times in order to get the total probability. Okay, so what's the probability of case 1? Well, again, the probability of case 1 was in the slot where the first block is produced, it's successful. So we have the probability of success to the first power, it happens one time, and then the probability of failure 4,319 times, okay, because there's 4,319 other blocks. What's the probability of case number 2? Well, remember in case 2, it failed in the first block, and then it was successful in the second block, so we take a probability of failure times the probability of success. Since it succeeded in the second block, it must fail the remaining 4,318 times. However, I can rearrange this so that we have the probability of success to the first power times the probability of failure to 4,319th power. Why? Well, because there's one here, and if I just collapse that into here, I can add the 1 over to that one, and so it ends up being that. Well, look, the probability of case 2 is exactly the same as the probability of case 1. Okay, so, well, that tells me that the probability of all the cases, all 4,320 of them, is going to be exactly the same. It's going to be probability of success to the first power, because there's only going to be one success, and then multiplied with the probability of failure, because it must fail the remaining number of times. So this is the probability for any case n, okay, where n is a variable that could either be 1, anywhere between 1 and 4,320. So the simple way to write the probability of producing exactly one block is that we're going to sum. Sigma just means sum, so it's a discrete sum, where n, okay, is going to run from 1 to 4,320, and the probability of case n, okay, so it's probably, what this means is the probability of case 1 plus the probability of case 2 plus the probability of case 3, all the way out to plus the probability of case 4,320. And so the way to write that is, because all of these probabilities are the same, we have the probability of case 1 multiplied by 4,320, because all the cases have exactly the same probability, and there's 4,320 of them. Okay, so that's just reasoning it out. That here is the probability of producing exactly one. So let's just calculate that out. 4,320. Again, here I've just dropped in the number for the probability of success, 0.8%, 99.92% chance of failure, but to the 4,319th power. And what it comes out to say is that the probability of producing exactly one block is 10.04%. So now we can summarize what we've done by saying, well, we have the probability of producing 0 blocks is 2.81%. The probability of producing at least one block, the probability of producing exactly one block is 10.04%, and the probability now of producing more than one block is 87.14%. And of course, this is all only correct for a pool that has 10 million active stake, that there's 12.100 billion total active stake on the network, and for a decentralization parameter of 0.8, which is true for Epic 212. Okay, so let's move on to another question, which is answered by the calculator on the website. What is the expected number of blocks produced? So, we have these probabilities, but okay, just tell me, how many blocks can I expect the pool to produce? Well, okay, so I'm calling that expected number of blocks B inside of these angle brackets here, okay? So this is the expected number of blocks that will be produced, and that's going to be the probability of success in any one particular point where a block is going to be produced, times the number of opportunities, right? Well, we said for the stake pools, there's 4,320 opportunities, again in Epic 212, and then of course the probability of success is 0.8%. So that comes out to be 3.57 blocks, or rounded up to 3.6 blocks. So, obviously a partial block can't be minted. So what this is saying is you could expect 3 or 4 blocks. That's a reasonable expectation. Now, because of the randomness, it could produce 0. It could produce 1. It could produce 6 blocks or 7 blocks. All right, but the chances of it producing 15 are small. Okay, so this sets your the general range of the expected success. Obviously, there's a chance, a non-zero chance, just as we saw up here. Okay, so you can go and you can calculate the probabilities. The probability that it produces exactly 1 block is 10%. I mean, that's a non-zero chance. So it could produce 1 block, but the best money, if you were if you were pressed to say how many do you think it will do, I would say, well, either 3 or 4 would be most likely. That's the reasonable expectation. Okay, again, because it's random, I would expect it to converge to this number. So, for example, the only way that this makes sense is we would have to run Epic 212 over and over and over and over and over again. And yes, each time it's going to produce a different number of blocks. And then, after we've run Epic 212, which we'll never do, Epic 212 happens once, okay? But if we ran it over and over and over again, 100 times, 1,000 times, you could expect that the number of blocks, the average number of blocks that the pool would produce over the 1,000 trials that we run and rerun Epic 212 would converge to this number, around 3.57. Sometimes it'll produce 0, sometimes it'll produce 6, but on the average it will get here. This number has less meaning when you're only doing 1 trial, but again, in the absence of any information, at least this is something. All right. So again, okay, the final question now that that we could answer is we could say how much stake is required. So the expected value number of blocks is 1. All right. So you could say this would be sort of like a lower bound on the amount of stake that your amount of active stake that your pool needs to have in order that it could be expected to produce 1 block. So the way that I will write that out is that the expected number of blocks, again, is equal to the probability of success at any one opportunity times the number of opportunities to produce a block. So we're going to put 1 in here, and so therefore the probability of success has to be equal to 1 over 4,320, which ends up being this number. Okay, so the unknown now is the pool's active stake. What is the minimum amount of active stake where you could expect the pool to produce 1 block during the epic? Well, so we can solve that because the probability of success is just the pool's active stake divided by the total active stake, and that has to equal the probability of success that we calculated above. So just multiplying that through, the pool's active stake is therefore going to be the probability of success times the total active stake on the network, 12.10 billion ADA, and that comes out to be about 2.8 million ADA. So in Epic 212, if your pool has at least 2.8 million ADA, it can reasonably be expected to produce 1 block, at least 1 block during the epic. And if it's higher than that, it may produce more. It could produce more with less than this. I mean, it could produce 1 with less than this. It could produce with 2.8. It could produce more than 1. Again, just a single observation of the epic, because it's only run once on the blockchain. You can't I mean, you know, you can't say it's going to be, this is the exact lower bound. Um, the only the point here is that if you ran it many times, then what you would find is that over the long term, any pool that had less than 2.8 million ADA um, would basically not produce any block, and a pool that had it, you know, 2.8 million ADA or more um, would produce one block or more blocks, depending on how much higher ADA it had in its active stake. Okay, so we've gone through the calculation, and I just wanted you to see that there's no fancy, uh, you know, statistics that's going on here. This is just reasoning it out, all right, and just doing simple math, simple calculations. This is exactly what is put into the calculating tool that is on the website here at arcadiastakepool.com. So you just come here, all of those calculations that you saw, well, I'm doing two of them, the two that I think are the most interesting, the probability of forging at least one block, this particular epoch, and then the expected number of blocks the pool will produce. And again, you have to realize that because of the randomness, it can be different from what's being calculated, but this is giving you the reasonable expectation. These numbers here were for 5 million. Now we just went through the 10 million, so just to show you that it's producing the same numbers, so I'm going to put in 10 million there and we'll resubmit it. And you can see the probability of forging at least one block, 97.19%, and the expected number of blocks the pool would reproduce is 3.6. If we come back here to the calculation, we go back up here to where we didn't expect that to happen. Okay, so that's interesting. Yeah, 3.57 blocks. That would be rounded up to 3.6. And if we come back, the probability of at least one block, that's up here a little bit further. Oh yeah, 97.19. What did I have here? 97.19. 97.19 exactly. Okay, so the calculator is working. It's doing exactly the calculation that I wrote out in that little you know, Blackboard presentation. That's what we have. Now, for those of you that are up for a challenge, I would challenge you to calculate what is the probability of your pool producing exactly 2 blocks. All right, so that would be the next thing to calculate. So I can tell you, you know, give you kind of a hint of what that would be. Is obviously you can see here from the case of it succeeding once, you multiply the probability of one success times the probability of failing the rest of the time. So for the probability that it will produce exactly 2 blocks, I would say that you're going to multiply the probability of success to the second power times the probability of failure to the 4,318th power, so the 19th. Okay, so the only thing that remains in order to calculate the probability of producing exactly 2 is you got to figure out what number is going to go over here. All right, what's this number going to be? Because we already know what this is going to be. This is going to be probability of success to the second power times the probability of failure to the 4,318th power. And then the question is, what is this number? All right, if you have listened to this video all the way through to this point, I challenge you to calculate what this number will be for the question of answering what is the probability that the pool will produce exactly 2 blocks. And if you write that number that would go here in the comments, and if you get it right, I will pin that comment in the channel. Okay, so under this video, if you comment the coefficient that should go here and you get that correct, I will, whoever does that the first, I will pin that comment. And I'm just going to give you a hint. It's much bigger than this number. Okay, it's much larger than this. So anyway, good luck with that. And it's been a pleasure speaking with you, going through this with you. Please visit our website here at Arcadia, stakepool.com. Look for the banner that we have on the front page of the website here. Try our new pool performance estimator. Click on that. It'll bring you to this page. You can enter the stake in here. I'll just try 1 million right now, and you submit that. And if you have 1 million, probability of forging at least one block this epoch, 30%, and expected number of blocks the pool will produce in epoch 212 is 0.4. Okay, so yeah, you're kind of, if you only have 1 million in active stake, the odds don't look that good. But 30%, there's still a chance. So, it can happen. All right, that is it. Again, here at Arcadia Stake Pool, we would be most pleased and proud to have you as a delegator. Please consider delegating your ADA with us. Our stake pool tickers are Atoms and Tesla, and I wish you happy staking.